Okay, how are you feeling now? Okay, so after the 3.1, so I hope you are not being overwhelmed by that. Okay, so now this one, you gotta have a clear mind in order to take this. Okay, so remember something about the one that I said in the previous chapter. Completing a square is for graphing. Okay, so it is important here. So now maximum and minimum values of quadratic functions. Okay, so let's move on this. Okay, toolbox to find min or max is the completing the square. Okay, still remember or not? If not, I do one question here. Okay, for example, you have this one. What you can do is to box out the x squared and 4x here. The constant, leave it outside. Then what you do, you add the middle term divided by 2, then you square it. If you something like add something here, then you have to minus it back, or else it won't be tally with this one, right? Okay, you see this? This and this, they are cancelled off. That's why if you don't have this one, means it's the same as the previous equation. Not equation, it's a function. Okay, so cancel this one off. This one is the same as this one. So you are safe to say that this is fx, this one also fx. Okay, next. Then I simplify these three terms. It is x plus 2 square, because what? Because a plus b, the whole thing square, is equals to a square plus 2ab plus b square. Okay, so that's why I collapse it back, you get this one. And I simplify these two terms together, I get -1, hence I get this one. So from this step to this step, you have done the process of completing the square. Okay, if you forgot it, you go to refer to chapter 2.2, methods number 3, completing the square. Okay, so that's it. Okay, so if a is bigger than 0, what will happen is that you have this smiley face, remember? Okay, so just a revision, this is the first slide. So I just want you to have some feeling about this one again. Okay, so has minimum point. Smiley, there's one minimum point, right? Maximum point, there's no, right? Okay, I mean, like, it can extend infinitely. It's a smiley face. Okay, it's a sad face, then it's something like turning down. So there's a maximum point, but no minimum, because it goes down like indefinitely. So next, so we will have a maximum point. Okay, no problem. Okay, so basic of sketching graph. This one is not actually something that that is very likely to be tested. Okay, but this is very crucial, and you should know this one. Really, it's very simple. Okay, let's say this is y equals x squared. Then what is the effect of the plus or minus of 1 or -1 and so on? Okay, let's see. A, b, and 0, you know. Okay, so what does it mean by plus 2? You see, you're plus 2 on which side? You're plus 2 on the y. Adding another 2, right? So what do you think the graph should look like? It's about shifting, you know. Okay, shift up, shift right, or shift left, or shift down. It should be shifting up, because y already add 2 there. Okay, so it should be shifting up. It's 2 here, then you should be doing this. Okay, if you don't get it, how about this? I said y equals 0, it's 0. I said y equals 0, I said x equals 0, it's 0 for y value. I said x equals 0, it's 2. So it's shooting up 2 steps. Okay, so it gives you this. Okay, next one. This is still a greater than 0. Okay, how about this one? Now I don't do anything about here outside. So meaning that I don't change something like the y, the height of the function. Okay, so now I change inside. I say x minus 1, the whole thing squared. So let me ask you this. What is the value that will make y to be equal to 0? Okay, you said y equals 0, then means x minus 1 square has to be equal to 0. Means x has to be equal to 1. So meaning that when x is 1, it is 0. So it will look like this. Okay, it shifts to the right. Okay, so how do you see? You see something bracket square. This is x. Then something like this one, -5. Okay, so then the point here is 5. You set inside to be equal to 0, and then x will be 5. Okay, let's say it is x plus 2, the whole thing square. Then you shift to where? You shift to negative 2. Shift to the left hand side. Okay, negative 2. Okay, let's do it. Okay, this is a is bigger than 0. Let's try again. Negative x square means a set face. Then I will draw something like a graph like this. Okay, then next, negative x square, but now I plus 1 means the set face I move up by 1. So it will look like this. Okay, then next one. So this one, I test you. Try yourself. Think about it. Okay, I don't want to reveal the answer first. Okay, 3 seconds, enough for you to figure out already. Alright, so now I have this one. Like I said, I let inside to be equal to 0. My answer will be negative 3. Meaning that this thing, it was a set face, but now you shift the center to negative 3. I shift to negative 3 and I do this. So you see how I shift? I can treat this as a pivot point. Then I shift unit up to here. Okay? Or I shift to the right here. Okay? That's how you see. Okay? I shift from the center 0, 0 to 0, 1. Okay? Here. Then I shift the center 0, 0 to negative 3 and 0. That's how I shift. Okay? So this one will be very, very useful in sketching graph. Let's say in your Form 5, you are doing something about integration. You need to sketch graph as well, okay, to find the area and so on. So this one will be very, very helpful if you know. Okay, right. So I hope you can get this, and we move on to the next one. Lesson 0. Okay, more example. Can you do this? This is slightly further. So now what I do, the y originally it was centered as 0, 0, correct? Okay, it was centered at 0, 0, and it's a smiley face. Okay, then now you know it's a smiley face, right? So I write it here. Okay, and this y value, it gets up by 1, so it shifts up by 1, correct? So then it's up by 1. How about this one? It is what? I move to the left or right? Right. Okay, because I want x minus 1 to be equal to 0, so x is equal to 1. So from the center 0, 0, you shift to the center, x is 1, okay? 1. Y also shift to 1. So it's 1, 1. So meaning that originally it was this, then now it moved to 1, 1 here. Okay? It moved to this. Okay? Original graph was here. Then now I move to here. Okay? This is 1, 1. Alright? So that's how you see things. Okay. This is minimum point. You get it? Minimum point. So how do you get the minimum point? You look at inside here and look at outside here. Inside here, how do you look at it? You let it be equal to 0. So x is equal to 1. So outside, you don't have to take minus anymore. It's just this value, so it's 1. Okay? So that's 1 and 1. Okay. So that's a bigger than 0, your minimum. Next one. Can you try this? Okay, so now I tell this y is equal to negative of x squared. So it looks like a set face. A is less than 0. Okay, the problem is now you have a maximum point. How do you see the maximum point? You want to look at the thing that is shift to. Where is it shifted to? You shift from 0, 0 with a set face to where? Okay, so think about this. Answer will be negative 2 and negative 1. Okay, here I let it be equal to 0, so x value will be negative 2. Then here, negative 1, I directly take the negative 1. So the graph will be negative 2, negative 1, then I plot this set face. Okay, that's the point here. That's the maximum point. Okay, then a is less than 0. Okay, correct? Right, one more. Try yourself, try yourself. You can do this. Okay, so tell me, what is the center that is shifted to? I shift the center or the maximum point for this case, okay, to where for this case? 5, 4, 3, 2, 1. Proceed. The answer is 1 and negative 2. Okay, so I shift to 1, and negative 2. Okay, so I plot 1 and negative 2, then I look at here. Oh, the x square is positive. Positive means it's a smiley parabola. So smiley parabola, and with the minimum point at negative 2, 1 and negative 2. Okay, minimum point. This is for a bigger than 0. So you get this one. Okay, so I guess you get the idea of this whole thing, right? Okay, how things shifted. Okay, if you know this, then everything will be very simple. Okay, very simple. Let's say I'll give you an example. Let's say fx is equals to x to the power 3. I tell you the graph. It looks like this. Okay, it looks like this. Okay, this is x to the power 3. Then now I want you to find what is fx equals to x plus 1 square, x plus 1 cube, then minus 3. Okay, so from here the center is here. Okay, let's say you take this as a pivot point center here. Okay, then now this one shift to where? Shift to, let's see, you do the same thing. This thing is said to be equal to 0, so x coordinate will be negative 1. So negative 1 here, I plot the point, and minus 3 here, I plot another point here, minus 3. So this is the center. Let's say I shift this one to here. How will the graph look like? It will look like this. Okay, so this is how you shift things. Okay, so this one is more advanced than this one, but the idea is totally the same. If you get this idea, you can sketch all the graph if you know the basic graph. Now the basic graph is what? Smiley or sad face. Okay, later on the basic graph can be this, can be others, and so on. Okay, no problem. Let's move on to the next one. Okay, conclusion. For graphing, you have a bigger than 0 and a less than 0, and if you have this kind of things here, a x minus h plus k. So you shift to where? You shift to h and k as a coordinate. Okay, so h and k will be your either maximum point or minimum point, right? For a bigger than 0, smiley, minimum point. For a less than 0, sad face, so it's maximum point. So what I do, I write this hk. So I draw at hk. So do you know what is the axis of symmetry here? You just look at the x values. X value is h. So x equals to h is the axis of symmetry. Okay, so here, same thing here. You do this, then you have axis of symmetry at x equals to h. You just look at here purely. Okay, so this is for this one point here. Okay, no problem with this. Okay, just a shifting. So here I write down the coordinate of the center or the maximum point. Okay, coordinate of maximum point is hk. Okay, and also axis of symmetry is x equals to h, not h only. H is the number. You say axis must be an equation of a line. Axis of symmetry, x equals to h. Okay, I'm just telling you that this point, the value is at h, not telling that this whole thing is h. Okay, right. Minimum, maximum point, also known as turning point. So sometimes the question will tilt a bit so that it can confuse you and like make you get lesser points. Okay, so that's why. Okay, this one, turning point. Later on we will learn this one. Okay, but not here. Meaning that this one can be combined in the later chapters, and just put one question there. Okay, so yeah, I'm just reminding you. Okay, so now I want to find the max min point and axis of symmetry. So tell me, this one, it's a what? Sad face or smiley face? It's a sad face, smiley face? It's a smiley face, okay? Because a is bigger than 0. A is bigger than 0, I have a smiley face. Smiley face, and how do I know the maximum or minimum point? It's smiley, so you have a minimum point. So no max point, minimum point only. What's the minimum point? I look at here, it's 1. I look at here, it's 3. So 1 for x, 3 for y, so 1, 3 here. Okay? Then Okay, so I label this point first. This is 1, this is 3, just a rough sketch for you. So this one is your minimum point, this one is your minimum point, and I'm drawing a smiley face. So that's very simple. So I'm drawing this. Remember, you can't draw this, you can't draw a V shape. This one, there's a sharp corner, so it's wrong. It's a smooth one, okay? It's a rounded one. Axis of symmetry, how do I know? It's at here, right? So I put the dotted line here. This value is 1. So it should be x equals to 1. Okay? It's the x coordinate. It's the x coordinate of is the axis of symmetry. Okay? This one is from the x coordinate of the maximum or minimum point. Okay? That's for parabola. So now for this function, it's okay for me to name it gx, right? Okay, it's the same. So exam, they can name it to be hx and so on. Okay, so for this one, it's a smiley or a sad face. Sad face, right? Yeah, great. So you got this one. So because -3 is less than 0, so it's a sad face. So now you look at the this one, you let it be 0, it's -1 and -2. So -1 and -2. So this one is a coordinate of min max point. Min or max? It's max. Okay, it's max point, not minimum point. So it's max point here. So you got this one is maximum point, but it looks like negative. Does it make sense? Yes, it makes sense because you can draw what? -1 is here, -2, let's say it's here. So this is -1. So I'll draw here, I'll draw here. Then I'm done. It's very simple. Axis of symmetry, what do? I draw a dotted line. Okay, then this value is -1, and I look at here, x coordinate is -1. Can I write -1 here? No, I have to write x equals to -1 because it's axis, it's a line. Okay, no problem. We can move on to the next one, right? Okay, so give you an SPM-like problem. So it looks like the things that will come out in SPM. All right, so you are given a quadratic function and you want to find a coordinate of max min point, meaning that you have to do completing the square. Alright, then after that you find y-intercept. How to find y-intercept? Y-intercept means on the y-axis, so you let x equals 0. Okay, axis of symmetry, look at the max min point. Okay, right, so let's start. This one, I bracket it. I want the coefficient to be 1. Okay, I want everything to be outside, the constant to be outside, and here, make sure you don't write wrongly. This is not 4 anymore. You bring out the 2. Then what I do? You add -2 divided by 2, right? Square. So -2 divided by 2 square, and you minus it back so that this is exactly the same as the previous one. These two terms will cancel off. Okay, then it will look like the same thing as the previous one. Okay, you can't allow something like simply add some terms there. Okay, so that is different. Okay, so I combine these 3 terms, then I write as x minus 1 square because x minus 1 square. Okay, 1 here is 1. It will be -1, the whole thing square, so it's still 1 square. Okay, x minus 1 square. Then after that it's what? Here you get -1. But then here, there's a 2. So you need to remember to multiply in. You get -2. And here +1. Okay? Upon simplification, you get this one. If you see this form, you should be professional now, right? Okay? You got this one, meaning that you shift to 1 and -1. Easy. 1 and -1. Coordinate on min max point is 1 and -1. Okay? I set this one to be equal to 0. Then this one, the value, I just take it. Problem? Okay, so anything you are not feeling good about this one, go back to 2.2 completing a square, method 3. Okay, so just do a revision on that. Right, so find y-intercept. Very simple. Y-intercept when x is 0, f0 is equal to 1. That's why y-intercept is just equal to 1. Okay, it's very simple, right? Okay, next. If I want to find x-intercept, what do? I solve the quadratic equation. Okay, means I find the roots for that equation. Okay, but for this question, it's only y-intercept, so I let x equal 0. Okay, So x-intercept means y equals 0. Means you're solving this quadratic equals to 0. Okay? Axis of symmetry, just now we talked about it already. Let x equal 1 equals 0, x minus 1 equals 0. So x equal 1 is your axis of symmetry. Just now remember, it was something like x minus 1, then behind that, I forgot already. Let me see. X minus 1, then minus 1. Okay? 2x minus 1 and minus 1. 2 square and minus 1. So it's 1 and minus 1. Okay? This is a coordinate of min-max point, right? So you are just looking at this one. Okay? Which is x equals to 1. Alright. So now, next one. Okay? I hope this is the last example. Okay? But very easy. 2 methods. Okay? Let's do the first one. You have maximum, minimum point, or I mean just minimum point for this case because it's smiling. Okay? Minimum point m and n. What do? I do this one. I do completing the square, middle term divided by 2 square, then minus, so that they are cancelled off, and this line and this line, they are the same. Okay, combine that part, so I get this one, and 2, 9, 2, 9, okay, multiply outside, then you combine, you get that one. So from here, you can directly see that m is your x coordinate, so it should be x plus 3 is equal to 0, so x is equal to minus 3, so m is minus 3, and n is 21. Okay, so minus 3, minus 21. Did I see plus 21? So it's minus 21. Okay, is that one? Okay, no problem. This one is like you do forward. Okay, I just solve the things. Okay, fine with first method. Second method. Okay, what do? I know the maximum, minimum point is this one. So I go backward. I do backward. We know a is equal to 2. So that's why if you complete a square, eventually it should have something like 2 something square, then plus something, right? Okay. This is x, then some value here, then this is some value. Okay. So we move backward. If we know the maximum, minimum point is this one, then we move backward and we will know this, correct? Minus the x coordinate, then plus the y coordinate. Is this what you have learned just now? Yes. You let this one to be equal to 0, then you get m, right? So you get m, right? Okay. Then you directly take this value n, so you get n. Okay. So we move backward, we do this, meaning that we expand it, and we expand this. So what we see, you see, we are trying to compare this one with this one. Okay, if you compare, we get negative 4m is equal to 12. Okay, the x coefficient. So that's why m is just negative 3. Okay, if you know that already, then you plug this into here, and this thing has to be equal to negative 3. This whole thing will be equal to negative 3. Okay, so that's what I say here. Alright, so 2 times 9, because this one you substitute it in already, then you move the things over to the other side, and hence n is equal to negative 21. So it's the same answer as the previous working. They both work. Okay, I guess this is more, this one requires you to have some knowledge about the things. Okay, so maybe this is harder to think, but if you can get used to this one, it's good. Okay, so it depends on you which one you want. Alright, so you have your answer here. Alright, move on to the next one. Okay, so exercise for today. So you're going to find the coordinate of max min point, axis of symmetry, sketch graph of fx for these 3 quadratic functions. Okay, so see you next time in a class. Alright.